Hello, my name is Oscar, and we're going to do the chapter 5 and 6 examination. We're going to start with problem 1, hammering a nail with a falling cylinder. So for this one, we have two different parts, part A and part B. And the values we have to start our problem is, our first value is going to be mass, which is equal to 20 kilograms. Our second value is going to be height, which is equal to 1.50 meters. Our friction force, which is going to be equal to 16 Newton. We have our gravity, which is equal to 9.8 meters over seconds to the power of 2. So for part A, we need to find the speed of the cylinder just as it hits the nail. So first we need to calculate our work done by gravity. So the work done by gravity, it's going to be equal to mass times gravity times height. So this is going to be equal to 20 kilograms times gravity, which is 9.8, times height, which is equal to 1.50. And our result is going to be equal to 294 joules. This is our work done, this is our work done by gravity. Now we need to calculate our work done by friction, which is going to be equal to force of friction times the height. So this is going to be equal to 16 newtons times our height, which is 1.50, and this is going to be equal to 24 joules. Now we need to find our network. So this is going to be equal to the work done by gravity minus the work done by friction, which is equal to 294 joules minus 24 joules, and this is going to be equal to 274 joules. Now we're gonna use the formula for work force. Now to complete the exercise, we're going to apply the work energy theorem, which is work net equal to 1.5 times mass times velocity to the power of 2. So we know the work net is equal to 274 joules, equal to 1/2 is equal to 0.5. Our mass is going to be equal to 20 kilograms. And we still don't know the velocity. So we need to isolate our velocity. So this is going to be equal to 0.5 times 20. It's going to be equal to 10. So 274 over 10 is equal to velocity power of 2, and the square root of 274 over 10 is going to be equal to velocity is going to be equal to 5.20 meters per second. So this is going to be the result for part A. So for part B, We need to find the average force on the nail. So we already have mass, which is equal to 20 kilograms. We now have our velocity, which is equal to 5.20 meters per second. And we have our distance, which is equal to 0.0300 meters. So to start with this, we need to find our kinetic energy first. And our formula for kinetic energy is going to be equal to 1.5 times mass times velocity squared. And this is going to be equal to 0.5. Our mass is going to be 20. And our velocity is going to be 5.20 power of 2. The result of this is going to be equal to 270.4 joules. Now we need to find the average force. So the average force formula is equal to kinetic energy over distance. So if we plot our numbers, if we plug our numbers, this is going to be equal to 270.4 over 2.00300. And the result of this is going to be equal to 9013.3 newtons. So this is going to be our result for part B. So the diagram for part A is going to look something like this. So we have a cylinder, and its mass is going to be 20 kilograms. We have the friction force, which is going to be when it hits the nail right here, or friction force. It's going to be equal to 16 newtons. The height between the cylinder and the nail, or the box where the nail is being hammered, is it's going to be 1.50 meters. And right here we have 0.0300 meters, which is the distance that the nail is being it's the distance of the nail inside the wood. So this is our diagram for problem 1 and part A and part B. So now for problem 2, we're gonna start with part C. This is about lifting a box full of fruit, and we are using a rope. So our mass is going to be equal to 14.5 kilograms. We have our tension, which is equal to 160 newtons. We have the distance, which is equal to 1.35 meters. And we have gravity, which is equal to 9.8 meters per second to the power of 2. So for part C, we need to calculate the work done by tension. So the work done by tension is equal to the tension times the distance. And this is going to be equal to 160 newtons times the distance, which is equal to 1.35, and this is going to be equal to 216 joules. So this is the answer for part C. So now for part D, we need to calculate the work done by gravity. So the work done by gravity is going to start with a negative, and this is because we are lifting the box. So this is going to be negative mass times gravity times distance. So this is going to be equal to negative 14.5 times 9.8 times the distance, which is 1.35. So all of this is going to be equal to negative 192 joules. So this is the work done by gravity, the answer for part D. For part E, we need to calculate our net work. So the net work is going to be equal to work of tension plus the work done by gravity, and this is going to be equal to 260 joules plus minus 92 joules. And the result of this is going to be 24.2 joules. So this is going to be the answer for part E, 24.2 joules, which is equal to the net work. And now for part F, we need to find our kinetic energy after lifting the box. So kinetic energy is going to be equal to work net. So now for part F, we need to find the kinetic energy after lifting the box. So kinetic energy is going to be equal to work net plus initial kinetic energy. So now we need to find the initial kinetic energy, and this is going to be equal to 1.5 times mass times velocity to the power of 2, and this is going to be equal to 20.5 times 14.5 times 0.5 to the power of 2, which is equal to 1.81 joules. Now with this result right here, we can find the kinetic energy after lifting the box. So kinetic energy is going to be equal to the work net, which is 24.2 plus 1.81, which is initial kinetic energy, and this is going to be equal to 26 joules. So this is the answer for part F, kinetic energy after lifting the box. And for part G, we need to find the final velocity or final speed. Part G. And our formula is going to be kinetic energy is equal to 1.5 times mass times velocity, final velocity or speed to the power of 2. And if we isolate final speed, this is going to be equal to the square root of 2 times kinetic energy over mass. And this is going to be equal to the square root of 2 times 26.0 over 14.5. And the result right here is going to be 1.89 meters per second. So this is the answer for part G, the final speed. So our diagram for part C is going to be it's going to look something like this. So we have our box. That is being lifted by a rope. So we have a tension of 160 newtons. We have a distance of 1.35 meters. It's being lifted it's being lifted with a speed of 0.5 meters per second, and the mass of the box is equal to 14.5 kilograms. And we have our gravity going down, our gravity and our mass. So this is how the diagram for part C will look. So now we're gonna start with our problem number 3, part H. Problem 3. And this is about an helicopter descending. So our mass is going to be equal to 1.40 times 10 to the power of 3 kilograms. Our first velocity is going to be equal to 3.00 meters per second. Our second speed is going to be equal to 0.450 meters per second. And our distance is going to be equal to 1 meter. So for part H, we need to find our initial kinetic energy. So for part H, initial kinetic energy is equal to 1.5 times mass times velocity 1. We're going to use velocity 1 to the power of 2. And this is going to be equal to 0.5 times 140 times 10 to the power of 2 times our first velocity to the power of 2, and the result of this operation is going to be equal to 6,300 joules. So our initial kinetic energy is going to be this, and this is the answer for part H. Now we're going to start with part I. So we need to find our final kinetic energy. So again, we're using the same formula, 1.5 times mass, but in this case we're not using the first speed, but we're using the second speed. So to the power of 2, and this is going to be equal to 0.5 times 1.40 times 10 to the power of 3 times 0 0.450 to the power of 2, and this is going to be equal to 242 joules. This is the answer for part I. With these two kinetic energies, kinetic energy 1 and kinetic energy 2, now we're gonna solve part J, which is we need to find our total work. So part J, which is where we need our total work, we're gonna have total work is equal to K2 minus K1, kinetic energy 2 minus kinetic energy 1. So this is going to be equal to 142 minus 6,300 joules, and this is going to be equal to negative 6,160. 6,160 joules. So this is the answer for part J, total work. Now for part K, we need to find the work done by gravity. So part K is going to be equal to the work done by gravity, which is equal to mass times gravity times distance, and this is going to be equal to 140 times 10 to the power of 3 times 9.8, the distance times 1.00, and this is going to be equal to 1.37 times 10 to the power of 4 joules. So this is our work done by gravity, the answer for part K. And the last part for problem number 3, we need to find the work done by thrust. So work of thrust is equal to a total work minus the work done by gravity. So this is going to be equal to minus 6,160 minus 1.37 times 10 to the power of 4, and this is going to be equal to negative 1.99 to the power of 10, times 10 to the power of 4 joules. So this is the work done by the thrust, the answer for part L. Now we're gonna complete part M, which is the real last part for problem number 3. We need to find the upward thrust force. So this is going to be force of the thrust is equal to the work thrust over D. So this is going to be equal to negative 1.99 times 10 to the power of 4 over 1, and this is going to be equal to negative 1.99 times 10 to the power of 4 newtons. But in this case, like, this is the upward thrust force. This is going to be positive, so negative 1.99 times 10 to the power of 4 is going to be positive 1.99 times 10 to the power of 4. This is going to be positive for the magnitude. So the answer for part M is going to be this one right here. So this is the last part for problem number 3. So now we're going to start with problem number 4. This one is different from the other exercise because we need to give the answers in terms. So we have mk, which is of our coefficient of kinetic friction. We have our mass. We have our gravity. We have the distance. This exercise is about a block sliding down an incline. So our distance is going to be the distance along the incline. And we have our angle, which is the angle of the incline. So incline angle. So now for part H, we need to give the work done by gravity in terms. So this is going to be work done by gravity is equal to mass times gravity times distance times the sine of the angle. So this is the answer for part H. What is our next? Okay, sorry, this is now part H, this is part N. So now for part O, we need to find the work by friction, but we need to give the answer in terms. So work friction is equal to the negative coefficient of kinetic energy. So this is going to be coefficient of kinetic energy times mass times gravity times distance times the cosine of the angle. This is going to be the answer. Now for part P, we need to give the speed at bottom. So we're gonna use the work energy theorem. So we have 1.5 is equal, 1.5 times mass times velocity to the power of 2 is equal to work done by gravity plus work done by friction. When we isolate the velocity or speed, this is going to be equal to the square root of 2 times gravity times distance, and in parentheses we are going to have the sine of the angle, and we're going to have sine of the angle minus the coefficient of kinetic energy times cosine of the angle.